Hi everybody, my name is Roberto, I am from Brazil and I will present my portfolio about computer graphics, computer vision, robotics and control of dynamic systems. First of all, RayTracing and PathTracing. That is an input file with scene description, lights, camera, objects, so on. This code was made in C++ without any library. To RayTracing, shadows, reflections, refraction and complex illumination were done. And beside these characteristics, to PathTracing, soft shadows and the inter-reflections, color bleeding were implemented. Then, what was done? C++ programming of data structures of camera, finishing, light ray, light sources, objects, textures, vectors. RayTracing, PathTracing algorithm. Found importance sampling around the perfect reflection ray, uniform sampling at hemisphere, parallelization with OpenMP library, reflection and refraction rays, Brussian roulette, supersampling to noise filter, blindfold specular and diffuse, light sources with area, Torrance spiral microfaces model with blind microface distribution. Both animations were done using shell script. This program in shell script changed in the input file the camera position and produce realistic animations. One can see that PathTracing animations are more realistic than RayTracing. So now I will present some exercise of computer vision done in MATLAB. In the first exercise it was evaluate noise in images and the frequency and phase representation of images. In the second exercise, histograms and an edge detector were implemented to detect edges in different images. The 3D reconstruction was done in C++. This reconstruction was done by successive pair of point clouds. Then rigid transformation to put all point clouds at same reference coordinate is done. The transformation of point clouds to voxel grid is the final step. In more details, the first step is detect key points with star detector. The key points are described by brand descriptor. This descriptor combines depth and intensity information, and it is very good to work with sensors like Kinect. Cross-check matching was used to find correspondent key point at 2-point clouds. Outliers are computed in key point matches using find fundamental math function of OpenCV. Using estimated rigid transformation of point cloud library, the cost alignment is done. The final step is use the algorithm ICP to define alignment. Considering the different images obtained, it can be observed that 3D reconstruction was performed successfully. This is due to the good performance of each algorithm step for 3D reconstruction by RGBD images. Robotics PathPlanning C++, potential fields. This technique was implemented in ROS and it was used stage simulator to show this technique. So, in potential fields, the robot suffers attraction from the target position and at the same time the robot suffers repulsion of obstacles which are in the range of the sensor. One can see that the robot direction is instantaneously changed according to the obstacles in the middle of the path. In the RRT dynamics implemented, the robot can ruffle a path to the right, left, or forward to perform its local path planning. In addition, it receives a topological map with an idea of positions that it should reach. In the same way as humans, local path planning is done according to the environment because it depends on the dynamics of the same. However, a higher level path planning is required to guide the robot to a destination. To map a environment, the occupancy grid technique was implemented in C++. According to the occupancy probabilities of a cell, the robot identifies a region of the map as occupied or not, increasing the probability of a cell being occupied or reducing it. In control of dynamic systems, a controller using Ziegler-Nichols PID was projected to a transfer function. Further, the electronic system. Furthermore, a electronic project of a bandpass filter was also projected with electronic circuit too. To measure the motor speed, a encoder was used and a set of Arduino and the DVD motor and the display. Combining robotics and control of dynamic systems, a self-balancing robot is built. This robot is composed by motors, encoders, Arduino, batteries, gyroscope, accelerometer, motor drives, and other equipment. To keep this robot in balance, the clock-driven scheduling of real-time systems is used. As one can see, this robot is capable to keep itself in balance.